Hello guys, welcome to the channel. I hope you all are fine and doing great. Today we are going to discuss the smallest number on left problem of GFG. So let's move on to the problem guys. So here we are given an array A of n means array containing n integers, and we have to find out the smallest number for every element on the left side, and that should be nearest as well. Suppose here is 1, here is 2, here is 6. Okay, then we can see the on the left the smaller number 2 6 is 1. 1 is the most smallest number, but we have 2 as well, so for 6 answer will be 2, because we have to find out the smaller number, but that should be near as well. Okay, so we can take 2 as well. It is not compulsory to take the minimum element. Okay, we have to just find the smaller element. Okay, if we have array 1 to 6, then answer should be like, for 1 we don't have any number, so answer will be -1. For 2 we have 1. For 6 we have 2. Now suppose if here is any number like 3, then here is number 2. Then for 3 the smaller number is 2, so for answer for 3 is 2. Now for 2 the answer will be 1. And suppose if here is 1, here is 1, suppose for a minute, if here is 1, then here is 1, then in the left side of it there is no number which is less than 1. So for this one answer will be answer will be -1. This one for this one for this. Okay, this is minus and this is just extra. This, okay, this is my answer, -1 1 2 2 1 -1 if my array is 1 2 6 3 2 1. Okay guys, so I hope you all understand. On the left side of it, the smaller number to a current number, we have to see out this. Now like for 162 -116 is -1 1 1. For 6 1 is smaller, for 2 1 is smaller. Similarly here you can try run. Okay guys, so this is a stack problem, and this is a very famous problem and very important regarding interview basis. This is very common problem for interview. Okay, I saw this problem on many places regarding interview preparation, so this is very important. So this is a very important stack problem, by the way. Okay guys, so what we will do, like suppose that's previous example, 1 2 6 3 2 1. Okay, 1 2 6, nothing, but you have to understand this. Now we take a vector answer, run a loop for each number. Now suppose we are currently point to this one. Now we have a stack, empty stack, initially empty stack, and we will push back -1, because -1 always be the minimum element. Okay, for each element, if we don't have any number, then we have -1, so we will push back -1. Means if our stack is empty, means for a current number, for a current ith number, we don't have any element in our stack that is minimum, that is smaller, then -1 is always available to me. Okay guys, so I will push back -1. Now for 1, I can see my stack is empty. Okay, or what I can say, I will compare 1 and -1. -1 is top, so -1 is less than 1. Yes, I will push back -1 in my answer and push back 1 in my stack. This is just a dry run problem. You just need to dry run it and you will go to it. Now I am at 2. Now for 2, you can see 1 is smaller than 2. You will push back 1 in our answer. Now we are at 6. Now for 6, and we will push back 2 as well in my answer. Okay, now for 6, you can see 2 is smaller than 6, so we will push back, means on the top of the stack. Okay, I will try. Now for 3, and I will push back 6 in my answer. I will push back 6 in my. Now for 3, is 6 smaller than 3? No, so it means I have to go back. Okay, now 6 cannot be my answer, so I can say for 3 6 cannot be my answer, so I will erase 6 from my stack. I will tell why. I will erase 6. So now 2 is less than 3. Yes, 2. So my for 3 my answer will be 2, and I will push back 3 on top. Now let's suppose if there is any number behind this. Okay, if 6 is here is, suppose it is 6, it is 3, and suppose here is any number x. Now if I am saying 6 is my answer for a current x, okay, it means 6 less than x. If 6 less than x, I can say 3 also less than x. Okay, because 6 is greater than 3, and but 6 is less than x. Okay, so what I can say, like this is like this. 6 is greater than 3 and 6 is less than x, so I can either way say 3 is less than x as well. Okay, so for a particular number, if 6 is fulfilling my condition, then 3 will also fulfill. Okay, because if 6 greater than 3, x greater than 6. Okay, or we can say 6 less than x, 3 less than 6. So 3 will always be less than x as well. Okay, if a particular x, if 6 is less than x, then 3 will always be less than x. So for any case, if 6 can fulfill my answer, then 3 will also fulfill my answer. Okay guys, so instead I can erase 6 now. I can take 3 because for each condition where 6 should be my answer, 3 can be my answer as well, and it is after 6. It is after 6. So I will take this 3 because you can see here 1, 2 and 6. I can say here 1 is also can be for 6, 1 can be my answer, 2 can be my answer, but I am taken 2. Why? Because 2 is nearer to me. Okay guys, now suppose for a simple case, here is 9. Now for 6, for 9, 6 can be my answer, 3 can be 3 can be my answer. So I will always prefer 3. Okay guys, so I can erase it, I can ignore it now. For all the remaining cases, I can ignore 6. Okay guys, that's why I am just pop out 6. Now I will push back 3 in my answer. Now for 2. Now guys, now for 2 I will see whether 3 is less than 2. No, I will need to pop out 3 as well. Now, if 2 less than 2, no, they are equal. I did find the smaller number. Okay, these are equal numbers, so this cannot be a valid answer. So 1 is less than 2. Yes, 1 is less than 2. So 1 is 1. So you can see in just OOM means I am maximum for each number. I am push his number at least 1 and pop out his number at least 1. So for each number, I am at most doing two kind of operation. Whose one is pop. So my time complexity will be O n. Why O n? Because for each n for each of the ith element, I am doing one push operation, one pop operation at most, and the time complexity of push and pop operation on stack is O1. Okay guys, so this is O n operation, O n time complexity approach. Now where we are at 2. Okay, so for 2, 1 2 3 4 5, 1 2 3 4 5. Okay, so for 2 we have pushed back 1, so I will push back 2 now. Now I am at 1, complete. I have at 1. Now 1 is less than 2. No, I will pop out this. 1 is less than 1. No, 1 is minus 1 is less than 1. Okay, mind that. 1 is 2 is less than 1. No, we need to pop out means we don't find smaller number yet. Now 1 is less than 1. This one less than no, we need to pop out. Minus 1 is less than 1. Yes, it is. So this is my answer, minus. So you can see minus 1 1, minus 1 1, 2 2 1 minus 1, 2 2 1 minus 1 is my answer. Okay guys, similar thing I am doing. I am taken a stack, push back minus 1, taken a vector answer that I need to return. Now for each integer, while my top element is greater than or is equal to my current ith element, I am removing it, I am popping out it. Then at last I am push back top element means top element of the stack at the current position after doing all the popping operation will be the smaller element that I need, and I will after push back this is my answer. I will push like I will push back 1, then 2, then 6 in my stack as well, and at last I just return answer. Okay guys, simple mathematical stack operation. If first time you are doing this type of problem, you need to try and else file. This is simple problem. So guys, all the 207 tests can pass out. I hope you understand the approach. If you have any doubt, then please comment out. I will try my best to explain you. So please subscribe the channel, like the video, and check out my channel for more these type of videos. I daily upload GFG problem of the day, and I also upload some good contest problem if I found. Okay, so please subscribe the channel, like the video, and check out my channel for more amazing videos related to coding. So thank you for watching this guys. Stay tuned.